Today I will show you the major feature of MIDAS server with the strong point why MIDAS server. This is the content we will go through. So I will briefly introduce you about MIDAS server, and then we will see the project applications using MIDAS server. And for the main features of server, we will see the general features and features by bridge type, such as the Corda bridge and segmental bridge or span by span method bridges, also the cable stayed bridges. And then we will also check the design features of MIDAS server. Starting from the overview of server. MIDAS server is 3D FEM software for bridges and civil structure. MIDAS server can handle from the simple static analysis to the advanced analysis, such as construction stage analysis or dynamic analysis. In the following slides, I will show you more functionality and strong points of server. What is MIDAS server? As many of you are not familiar with server, I would like to start with giving you general knowledge of MIDAS server. MIDAS server is, as I just mentioned, it's FEM-based software for 3D structure. And server is not for the special purpose. Server can be applied to any type of the structure, as it is the general purpose software. It is mainly for the structural engineer. If you are interested in the geotechnical engineering, then you can go to another MIDAS family software, which is called MIDAS GTS or MIDAS SolidWorks. Civil mainly designed for bridges and underground structure. Civil is not only for the analysis software. We can also do the design as per the Eurocode. What kind of bridge type we can apply MIDAS Civil? Civil can be applied from the conventional bridges, as you can see, frame bridge or slab bridge, integral bridges, even the PC or steel plate girder bridge, steel box girder bridge. We have many strong points for state segmental bridges like FCM, ILM, or MSS method, or FSM method bridge as well. And finally, we can also use MIDAS server for the cable stayed bridge and suspension bridge. Actually, we have a lot of project application for the cable stayed bridge because MIDAS server provides the optimized function to find the optimal cable forces. We will see more details in the following slides. As Romania is the high seismic zone, you must be interested in the seismic analysis. Civil can handle this seismic analysis from the simple response spectrum analysis. For response spectrum function, we can use the implemented functions. Also, if you have your own function, we can also define the function with the user-defined user type function. In this table, we can simply copy and paste the data from MS Excel. Also, we provide the pushover analysis feature. So from the additional module, which is called MIDAS GSD, we can calculate the momentum curvature curve for any shape of this section, and then we can automatically bring it to civil for this pushover analysis. If you want to simulate the dampers or isolator, we can also do that by performing the nonlinear time history analysis in civil. Also, for checking the nonlinearity of the member, we can go for the inelastic time history analysis. If you are dealing with the layer bridges, you may be wondering if MIDAS server can handle layer structure interaction. Yes, MIDAS server can do that. By using the multilinear type elastic link, we can consider the interaction between the layer and structure. If we want to check the dynamic effect especially for the high-speed train, we can also do that by performing time history analysis. We recently implemented additional module for layer structure interaction. So any very complex type of the modeling can be very easily done using the wizard. From wizard, we can generate the layer and structure and the link between the layer and structure. Also, the boundary condition rules can be specified for the particle train load and braking or acceleration load from the train. Also, the temperature load can be simulated. How to simulate the effects of nonlinear soil property in integral bridge? If you need to design integral bridge, you need to simulate the effect of nonlinearity of soil. For this, MIDAS server provides multilinear type point spring support. Also, the program can automatically calculate the soil stiffness by entering required data such as soil type and subgrade reaction. The other way is performing the dynamic analysis. We can also simulate the soil interaction from the time history analysis. In this case, we can simulate the soil stiffness using the 6x6 stiffness, mass, and damping matrix. Does MIDAS server support code check as per Eurocode? Yes, MIDAS server provides most of the latest Eurocode design feature from the material and section database, also the response spectrum function and pre-stress loss, also moving load analysis for the vehicles and late trains. For design, we provide the ULS and SLS design for RC structure, steel frame, also steel composite girder design for the steel plate girder as well as steel box girder composite design, and pre-stressed box segmental girder bridge. We can also do the design. If you are dealing with the irregular shape of the section, MIDAS GSD will be used for checking the moment curvature curve and also the stress distribution for any shape of the section. So for the European users, MIDAS server must be very useful not only for the analysis but also for design purpose. What kinds of the reports we can obtain after analysis and design? MIDAS server provides very useful tool which is called dynamic report generator. Using this report feature, the MS Word will be opened inside of MIDAS server, and then we can enter any of the data like the section property or any results like beam diagram or the beam forces table, reaction table, so on. If there is any change in your model after you generate the report, in that case, you can simply click Regenerate button. Then, program will automatically update the older report results based on the model file that you have modified. Also, as a result of the design, we can see the very detailed Excel format report, also the one page, the graphical report. So as a result of the design, MIDAS Civil is not like the black box. Civil will show you all the parameters and the equations and midterm calculation as well from this Excel format report. So it must be very useful for verifying the design results and then make your own report as well. For advanced analysis, such as wind-induced vibration, we have another software which is called MIDAS FEA. MIDAS FEA can handle CFD analysis and fatigue cracking analysis, which cannot be performed in MIDAS server. So if you are interested in this type of the analysis, you can use MIDAS FEA. For your information, the data between MIDAS server and FEA can be imported and exported to each other. So you can use both software. So mainly for the frames, we can go for the server, and for the advanced type of the analysis or the complex meshes, we can go for MIDAS FEA. One of the biggest advantage of MIDAS server is easy to use. MIDAS server provides very intuitive user interface. We can check all the input data from this worktree, so it will prevent your modeling mistake. You can check in the real time which data has been entered. Also, if you want to assign any material or section, you can simply select the desired element and you can drag and drop from this worktree. All the data, the modeling input data, also the results can be viewed in the Excel comparable tables. Also, we provide the free online training, and based on your request, we can provide you the customized web session. If you have any question during testing MIDAS server, you can send us the question by email. Then based on 24 working hours, we will get back to you with the answer for your queries. MIDAS server has been sold more than 70 countries, 8,000 licenses worldwide, and a lot of the world-leading engineering company is the user of MIDAS server. Before we go to the features more detail, I would like to show you briefly for the application of server. We choose 20 bridges worldwide. Firstly, Ironton Russell Bridge in US. This is the cable state bridge. As you can see, they use the cable optimized function to find these cable forces. And another cable state bridge in Ohio, US. It was designed from the Michael Baker Jr. They also use the construction stage analysis and cable optimized function. And this bridge is in Mexico. This is the one-cell PSC box cutter. The construction stage analysis and the vehicle load optimized analysis has been applied. And another steel bridge for roadway. Response spectrum analysis and moving load analysis was performed. This is the two-cell box cutter bridge in Mexico City. Construction stage analysis with considering the substructure, as you can see from this picture. Moving load analysis has been performed. And another bridge in Colombia for the PSC box cutter. And this bridge is in Belgium. As you can see, the complex shape of the bridge has been analyzed using MIDAS server with the cable optimized function. And this is the railway bridge in Netherlands. And this bridge is in Russia. Story Project was the designer for this bridge. And another bridge in Russia, St. Petersburg. And this bridge has been designed for, it is located in Romania. This complex shape of the girder has been simulated using the equivalent girders with the proper value of the sections. As you can see, we modeled all the substructures, and for this bridge we have simulated bearing isolator and viscose damper. So time history analysis has been done for this bridge. And another bridge in Russia, as you can see, a lot of cable stayed bridge has been designed using MIDAS server. This is the extradosed bridge in Vietnam. Extradosed bridge is like the cross between the girder bridge and the cable stayed bridge. And another bridge in Vietnam, suspension bridge. And this bridge is in Korea, the steel arch girder bridge. Also another extradosed bridge in Korea. And Yeongjong Bridge, which is the world's first 3D self-anchored suspension bridge. And Incheon Second Bridge, which is the 5th longest cable-stayed bridge in the world. It has been also designed using MIDAS server. And Stonecutter Bridge in Hong Kong, which is second longest cable-stayed bridge and world longest cable-stayed bridge at the moment, Stone Bridge. Also, the following the longest bridges which is under design is also designed using MIDAS server at this moment, like the Lusky Island Bridge in Russia. So let's see more details for the features of MIDAS server. I briefly mentioned you about the intuitive user interface of MIDAS server. The reason I mentioned it's intuitive because of this worktree and the Excel comparable table, which can be directly exported to MX Excel, or we can simply copy and paste it from Excel as well. And here you can see the task pane. For example, if you want to perform pushover analysis, program will show you the required step here, and then perform analysis. Then the related results can be viewed as a one list. So it will be like the guide for the advanced type of the analysis. So you do not need to hesitate from the main menu. And the graphical display is very powerful in server. This shows the stresses and the cutting plane diagram. And from the solid element, we can see the isosurface values and the deformed shape with the nodal deformation as well as the real deformed shape. And analysis speed is also one of the strong points of server. We have the latest analysis algorithm with the multi-frontal solver, which give us the accurate and also very fast analysis results. So if I show you with the program briefly, I will show you the general procedure of the modeling and checking the results. This is the framework of MIDAS server. We can see in the tabbed menu for all the results, and we can check the enter the data from this worktree. So from this start model, I have entered some of the material and section, and tandem property. And I mentioned you about the task pane. So for example, for the pushover analysis, we can see the required step here and post-processing in here. So let's try to generate the FCM bridge. We can start from the scratch to generate the line elements, or we can use the wizard. One of the advantages of Civil is providing the very practical wizard. I'm going to use the FCM bridge wizard. This wizard can be used for the typical shape of the bridge. If you have a multi-curved bridge, like some complex shape, in that case, you can use just the general feature of modeling, like generate the beam elements and then define the material section, so on. When we use the wizard, we can go define simple information for the geometry and section and tendon. Once I click OK, this complex type of the bridge with the tapered section has been automatically generated. Also, not only the geometry, the construction sequence has been entered. So with the changes of the construction sequence and the tendons, as you can see in here, we can see each of the step up to the final stage that key segment has been installed. As I mentioned, all these input data can be viewed from this worktree. After that, we want to consider the time-dependent effect. So we can go to the clip and shrinkage. We can use the CBFIP or Eurocode, or if you have your own function, you can also go for the user-defined. Generally, this user-defined is very good to use the clip and shrinkage data obtained from the construction field. We can use the European standards. By entering this simple data, we can check the creep coefficient and shrinkage strain. Also, one more for the different compressive strengths. Also, we can define the function for the compressive strengths. I will also use the Eurocode. As this is the mean compressive strength, I will define the value for the mean value. We can check the graph at the same time. Similarly, I will enter the one more function. Okay, so the functions has now been defined. Then what we need to do is simply making the link. By selecting the material, then we can make the link. So all the data has now been defined. We can save the model. Then I will open another model file that I pre-performed analysis. So this is the same model. I pre-performed analysis, and then we can check the result for each of the stages. For example, if I want to see the beam moment diagram for starting from the first stage due to the dead load, for example. from the first stage for each of the stage up to the final stage. We can check the force effects, and if we want to check the reaction, it's same. Select the desired stage, for example the final stage, and then we can see the reaction values. All the results can be viewed in the table format as well. With the desired stages, we can check these results in the table, and as I mentioned, all the results can be directly exported to MS Excel. Even we can simply copy and paste from here to Excel. And if we want to check the tendon related results, we can go to the results table and tendon. We can see the tendon coordinates and tendon elongation, tendon arrangement table, loss table, and tendon stress limit check. MIDAS is very practical, and a lot of engineer who is mainly dealing with the PSC bridges, they like these results, like the very practical results. Not only the tendon results, I mean the tendon primary force, secondary force separately, like, and creep, shrinkage, dead load effects separately. Since many results are very well organized, so civil must be very useful for your practical design. So if we check the tendon loss table, we can select the desired tendon from here and then select the desired stage, and then we can see the values. Even we can check the tendon loss graph with the changes of the construction stage. We can see these effective tendon forces. And if we want to see the girder forces or stress as a graph, we can also check it using the beam girder diagram. In the final stage, due to the dead load, for example, I want to check the stress at the bottom. So we can see in the graph format for this stress, even we can specify the desired allowable stress in this value, and then we can check at the same time the allowable stress line and the current stress values, whether they are exceeding the allowable stress value or not. And all these results can also be saved as an image format or text format with the proper values. So these are the main features from the modeling to the checking results. Let's go back to the presentation. And now I would like to show you with the features by bridge type. Starting from the most common type of the bridge, girder bridge. For the girder bridge, we can choose the type of the model, whether we want to use the simple beam element or we want to use the plate element. Any type of the modeling is supported in MIDAS Civil. So as you can see in this picture, we can use the beam element. In this case, one single beam can simulate both the main girder and the deck. Or if you want, you can directly model the plate elements, and then we can make the link between the main girder and the deck. If I show you with the model briefly, So this is the 1D beam element as you can see in this picture. But if I display its section, we can check the main girder and deck at the same time. And in the first stage, we can model only the main girder, and in the next stage, deck can be installed. So even though it is 1D structure, 1D beam element, we can simulate the before and after composite action using MIDAS server with the composite section. So from this composite section, we can simulate the deck and main girder parts. We provide the various type of the composite section, and using the composite section for construction stage data, we can simulate this before and after composite action. As I mentioned, we can also model this type of the bridge using the plate elements. So if we check the plate model, we can see the plate model here. I will try to display only the certain parts. So from this model, as you can see, when we use this plate 3D model, we generally simulate the cross frame and diaphragm in the main modeling. And in order to consider the connectivity between the main girder and the deck, we can use the link. In this model, we have modeled the elastic link, and the support has been modeled at the bottom of the main girder. So from here, by modeling the elastic link, this connectivity with considering the height of the hunch has been simulated. So any type of the modeling is supported in MIDAS server with the various construction stages. So this is the composite section dialog box that I just showed you. So we can simulate the deck and main girder with the 1D element. And when you generate the model, you may need to have the tapered section for some of the bridges. Tapered section generation is also very simple and easy in MIDAS server. If we check with the program, this is the another composite bridge. As you can see, main girders are modeled using the 1D element, and it has the I-shaped girder and the deck. From this bridge, this has the identical section for each span. I want to model the tapered section for this part up to the pier table. I want to have the symmetrically increasing section height. For this, what we can do is, firstly, we can generate the tapered section. For the I and J section, we can simulate the different sections using the predefined general section. After generating the taper section, we can assign the section to the girders. For this longitudinal girder, we can assign the taper section. Also similarly for the right part, we can assign the taper section. But at the moment, shape of the section is different from what we want. We want to have the the continuously increasing height, not like this shape. For this, by using the taper section group, we can simply generate the complex taper section. So our tapered group 1, I will assign it to these elements. It will have the continuously increasing starting from this end. So it will be polynomially with the second curve. And by clicking Add, you can see the taper section has been just generated. Similarly, for this right part, TG, I will name it as TG2, and then now it will have the shape like this. So by clicking Add, this complex shape of the taper section has been very easily and simply generated using MIDAS civil. After defining this taper section, we can check the section property for the I end and J end separately. And this is the segmental bridges. MIDAS civil provides the various bridge wizard. We already checked balanced cantilever bridge wizard. Also for the incremental launching method, we can see the changes of the support. We can assign the tendon at the top and bottom flange as well as the web. Also, full staging method and move-over scaffolding method bridge can be modeled. For the pre-stressed bridges, we can consider the effective width, which occurred due to the shear lag. And we can also generate the tapered section easily using the PSC wizards again. If we check with the program for this PSC wizard, this bridge for now has the identical section. And we want to use the PSC wizard for generating the tapered section, also for assigning the reinforcement. For this, we can define the section information first, and then we can specify the tapered section information, like the height or width tapered or top flange tapered. Like various type of the taper section can be generated using this wizard. Also, rebar can be entered. If we have the taper section, the defining the bottom rebar must be very complex and tedious work. For this, we can easily enter the bottom flange rebar by entering certain concrete thickness, the cover concrete thickness. By clicking OK, we can generate the tapered section, as you can see in this picture, for the PSC section, and the reinforcement has been entered, as you can see. For each of the section with the changes of their heights, the bottom rebar has been properly entered. And if we move to the Grillage model, we provide the Grillage model wizard for the multi-cell box girder. So this multi-cell box girder can be simulated using 1D elements like the spine elements, or we can model it using the Grillage model. For this, we provide the wizard. So the layout of the bridge and span, section, loads, and the tendon reinforcement data can be automatically entered. After we perform the global analysis using the full model, then we want to check the local effect, like the stress distribution from this multi-cell girder, or we want to find the most critical vehicle position, the lane position. For this purpose, we can use the transverse model wizard in MIDAS server. Again, if we check with the program, from this model, we want to extract one part of the girder to the transverse model. I want to extract the element number 23, which is this near to pier. For this model, I defined the model data like the pavement and barrier, which will be simulated as a load, and the other type of the load like the self-weight and the temperature load, also the live load. And if required, we can also assign the tendon and reinforcement. By clicking export, the additional model will be automatically saved. And I will open the generated model file. So from this model, as you can see, the transverse moving load analysis data has been entered to find the most critical lane position, and the loads like the temperature loads and the collision loads, pavement and barriers, which was simulated as a beam load. So by performing the analysis, we can check the critical vehicle position, as you can see in here. Even we can check the forces, for example, due to the temperature loads. So just like this picture, the local effect, which cannot be reviewed from the global frame analysis, we can do it using the transverse model wizard. So as we just checked, this transverse model is automatically generated. Defining the tendon is also, you must be very interested. So we can enter the tendon using the coordinates, or if you have the AutoCAD data, then we can import the tendon profile using tendon profile generator function. So this shape of the tendon can be generated. In this case, we need to have the AutoCAD file in the 2D. So XY and XZ direction, two different lines should be there. Then we can import into this 3D model. We have checked tendon related results. So we can see the tendon losses table and the graphical format. In the table, we can see the immediate loss and the long-term loss separately. Also, due to the creep and shrinkage effect and the relaxation loss and immediate loss in different tabs. So we can review the results with the different components. Also, for the pre-stressed box girder, we can check the camber. This is for the FCM bridge. We can check the camber value at the top of the table, and we can review with the changes of the construction stage how the camber value is going to be changed up to the final stage which has the 0 value. This value can be viewed in the graph as well. For the island bridge, node tip deflection is most important value. We can also check the node tip deflection using the stage history graph. And minimum and maximum stage is provided for checking the envelope results. So we can check the deformation or the member force reactions as the envelope value very easily. As you already checked our application, we have a lot of the project application for the cable state bridge. Because of this useful tool, cable optimized function. First of all, we can generate the cable bridge using the wizard very easily. So again, we can check it with the program. I have pre-entered the data for the self-weight and the only material and section. We can go to the cable state bridge wizard. What we need to do is just to modifying the material and deck and the section data. After entering this data and enter the layout for the bridges, and we can see in the real time how the bridges will be generated. So this cable state bridge has been automatically generated. After that, what we need to do is finding the cable forces. For this purpose, we can use the unknown load factor function. So based on the concentrate condition, program will provide you the cable pretension force. So before applying unknown load factor and after applying unknown load factor, we can see the changes of the beam moment diagram. And in the construction stages, if we want to find the Lego fit force, we can also do that. So after analysis, this Lego fit force will be considered to find the jacking force of the cable. And for tuning the cable forces without performing analysis several times, we provide the cable force tuning function. So by changing of the cable forces, in the real time, we can check the beam moment or the other cable forces or deformations in the real time. So it prevents you to re-performing analysis again and again many times. And camber is also important for the cable state bridge. We can check the general camber or manufacturing camber value. So we have checked the useful features by bridge type. Let's go into the design feature. I mentioned at the beginning, MIDAS provides the various design features for the PSC bridge and RC, steel, and composite girder bridge. Starting from the PSC bridge, we can check it with the program. This is one of the tutorial model of MIDAS server, and we will try to show you the design feature. For the PSC design, we can go to the PSC tab. We provide the American and Canadian Eurocode. We will perform design as per the Eurocode. For the serviceability checking, we can classify the load combination into quasi-permanent, frequent, and characteristic. If you use the auto generation function for the load combination, this data will be automatically entered. And for the stress verification, short-term and long-term load case can be classified, and their exposure class can be entered. After defining the desired data, then we can perform design and we can check the results. I pre-performed the design, so let's check the results. As you can see in this table, MIDAS Civil provides the design results for the flexure strength, shear, and combined shear and torsion. This is for the ultimate strength design, and for construction sequence, we can check the stress of the cross-section for each of the stage, and the tensile stress for the tendon, and also stress at the service load. Also, the principal stress can be viewed, and crack width check can be verified. If we go to the table, we can check the results. The results displayed in the red color means they are not satisfied, so redesigning is required with changes of the certain parameter like the strength or the tendon or the reinforcement. So we can check the design moment and the resistance and their ratio. Also for the shear strength check, we can see similarly for the resistance due to the concrete and the steel, and the maximum resistance limit and the ratio value can be viewed. So similarly, the member which are not satisfied by the design shear force, they are marked as NG and with the red color so that we can easily verify them. If we want to see the stress for the construction stages, most critical stage can be viewed for each of the elements, and their top and bottom, the stress value and the allowable stress value can be viewed. After checking the results in the model view and the table, we can also export the MX Excel format report. So if I show you the report, this type of the Excel format report will be generated. So for each of the elements, we can check all the equations and parameters, how they has been calculated, whether they are OK or NG. We can review all the design procedure with the equation in this detailed report. So it must be very useful for your design report. Not only the PSD design, we have the reinforced concrete design as per Eurocode 2. So if we go to the program again for the RC design, for the RC design, we can go to the Design tab and then select the desired code as Eurocode. We can specify the partial safety factor and serviceability parameter for the stress, crack, and deflection verification. And then we can perform the design. I will try to perform the column design, and then we can review the results in one page graphical report that I mentioned. We can verify whether the axial load or moment resistance exceeds their member force or not. We can check the ratio at the same time, and PM interaction is used for reviewing the column design results. Also, for beam design, we can check the results in the one-page graphical reports, or detailed text report. From here, we can see all the design parameter and negative bending moment capacity with the neutral axis position, and the positive bending moment capacity and shear capacity value. So all the detailed results can be viewed in the detailed report. For the steel design, it's same. MIDAS will provides the design feature as per the Eurocode 3. We can see the design for this type of the section shape, and the graphical and detailed report will be provided. Finally, for the girder bridge, steel girder bridge, we can perform design for the steel plate girder and the steel box girders as per Eurocode 4. So if we see it with the program again, we can find the design menu under the design tab, composite design. As per the Eurocode 4, we can specify the partial factor and the stress limit value and the shear resistance factor, and these results will be provided after performing the design, like the bending resistance and vertical shear, lateral torsional buckling, and transverse force, longitudinal shear, and fatigue. Also, the stress limit and the longitudinal shear serviceability verification can be provided. We can enter the design parameter which is required for obtaining these results, like the reinforcement and the stiffener, shear connector, transverse stiffener, so on. After entering this data, now we can review the results. For the flexure design results, similarly, we can review the member force and the resistance. For the vertical shear also, we can review the moment and shear force and their resistance. Also the stress limit. We can check for the steel plate girders, top and bottom flange stress verification with the allowable stress, and also for the concrete deck and the reinforcement verification. For each of the components, we can check their verification results. And it's same. We provide the Excel format reports. By clicking this menu, we can see the Excel format reports that I pre-generated. So we can see the design parameter like the partial factor and material strength and section properties, and then bending resistance verification with the all the equations, bend parameter, and the vertical shear verification, and the lateral torsional buckling, and fatigue, and stress limit. Also the longitudinal shear verification for each of the elements that we have predefined. So this must be very helpful for your verification. So that's it for the civil introduction. Before we finish, I would like to show you the upcoming conference, which will be held in the November 5th. So we are going to have the MIDAS technical conference in the Bucharest University in November 5th. As you can see, famous lecturers will attend to give you the lecture so we can share the new trend of the technical issues. You can see the link for the registration. So we can make the registration here. It's a free technical seminar, and also we will provide you the lunch, and also there will be the present for all the attendees. So we hope to see you in Romania upcoming technical seminar. So that's it for the MIDAS Civil presentation. If you have any question, please use the questions window. Then I will answer for all of your questions. We have one question. Does MIDAS can import the GN file, the microstation file? I'm sorry to say that we do not provide the data import or export function for microstation. MIDAS Civil has functionality for importing the other FEM software like the SAP or STAT and MSC Nastran and also LUSAS, but no data transfer from microstation. Also recently we have the feature for exporting IFC format file, but only export will be supported for this IFC format. The other question for the geotechnical model. I mentioned to you Civil is mainly for the structural engineer, and we have another software GTS for the geotechnical engineers. So the difference between two is Civil can simulate the soils using the spring only. So using the nonlinear spring or the linear spring, we can simulate the different soil PY curve, as you can see in this dialog box. But what we cannot do using Civil is we cannot check the behavior of soil. I mean, if we want to check the behavior of soil, then you have to model soil using the solid element, which can be done using MIDAS GTS only. So that nonlinear property for the solid elements for the soil that cannot be done using Civil, that can be done in MIDAS GTS. So for the soil structures, we can simulate the springs, just like this picture again. We can model the pile using the beam element, and we can model the nonlinear or linear spring with the damping, even the 6x6 matrix for simulating this soil stiffness. And then we can perform the time history analysis. That can be done using Civil, but not checking the soil source, the nonlinear behavior itself. How the vehicle load optimization works. I will show you with the program. So MIDAS Civil provides the Eurocode vehicle load feature. So this is the one of the model file for vehicle loads. So these are the supported moving loads code. As you can see, Eurocode is there. And then what we need to do is defining the lane first, the design lane. So we can specify the lane width and wheel spacing and the reference elements. Also, we can specify the area for the remaining area. And for defining the vehicular load, we can use the standard type vehicle, like the program already specified the vehicle loads as per the Eurocode. So load model 1, 2, 3, which is the special vehicle, and load 4. Also the footway and footbridge vehicle load, or fatigue load model. Also the train loads, LM71 or SW02 unloaded train, or HSLM, which is for the high-speed train. All of them can be simulated. So what program do is performing the influence line analysis. So if I show you, program performs the influence line analysis. For example, with this influence line analysis, then what we can check is we can see the most critical vehicle position. So from here, we can specify the desired elements. I performed the analysis for the results group. For example, for this element, where is the most critical vehicle position? This is the vehicle position, and the value of the vehicular load for the point load and the distributed load can be viewed. So in this graphical format, and the maximum value for the moment can be viewed. We also provide the concurrent force. As you know, if we check the bending moments due to the moving load, for example, these bending moments can be obtained, but their vehicle position for all of the elements are different. And also, if we check in the table, For example, for the element, let's say 171. The vehicle position, that shear force becomes the maximum and moment becomes maximum. Their vehicle position is different. But for design purpose, you must need to know the concurrent force. For this, we can simply right-click from the table. I want to see the concurrent force when this moment becomes maximum. This moment is 1591. So we can go to the same moment value. At the same time, what is the shear and torsion? We can check in this table, view by maximum value. So not only the envelope results, but also the concurrent force can be viewed in the table. If you are interested in the user-defined or any special shape of the vehicle, we can also simulate the vehicle using the user-defined format. So we can specify desired adjustment factor or axle load, and same for the load model 1, 2, 3, 4, even the straddling vehicle and the fatigue load model. We can simulate the vehicle loads. If you have any other question, please use the questions window. Also, just for your information, you like the LM3 vehicle, which is the special shape of the vehicle, you may need to simulate the special shape of the vehicle. Like the number of wheels in one axle is not only 2, but like 4 or more. In that case, we can use the permit truck. Permit truck is supported at the moment as per the H2 standard, but this permit truck is going to be implemented in the upcoming version. This is under the development. So in the user-defined vehicle, you will able to see the permit vehicle, which can handle this shape of the irregular, any special, the heavy vehicle. One question for the moving loads again. Do we need to model 3D model for this vehicle load optimization, or can we use the single beam model? You can use any. We can go for the 3D model and we can go for the single model. If you use the 3D, I will show you with the dialog box for the lane definition. So if you have just one line for the gutter, in that case, when we define the lane, we can use the lane elements. Then the vehicle load will be distributed along with the 1D beam elements. But if you have this type of the 3D model, the grid model, then we can go to this cross beam type. Then the vehicular load will be distributed with considering the transverse beam. So both are supported in Civil. The other question, can we export the load cases in the table format like Excel? Yes, we can do that for each of the load type. First of all, for the load case, we can simply copy and paste from this table. We can copy and we can paste it to MS Excel, or for each of the load, for example, the beam load, we can go to the table and all the data can be copied and exported to MS Excel. So we can simply copy this data and then in the MS Excel we can paste, as you can see here. Also for the load combination, if you have defined load combination in this spreadsheet form, we can similarly copy and paste to MS Excel, as you can see in here. So all the table format data can be copied and pasted to MS Excel. And the other question for the response spectrum function, I will show you also with the another model file. Just a second. For the head of the load combination, the question. So I just showed you the load combination from here. But so at the moment, when we just simply copy from this table, then the no head will be copied. But just for your information, you may remember that we have the function for the dynamic report. So for this root combination, we can export the file into the text format, but if we directly copy it from here to MS Excel, no title is copied, only the values are copied to MS Excel. And the other question about the general procedure, what we need to consider in a response spectrum function. So in the response spectrum function, first of all, we can go to the seismic, and then we can specify the desired response spectrum function here. So we want to define the Eurocode function. Then we can specify the desired spectrum type, horizontal elastic, vertical, and horizontal design. So depending on the type, we can see whether the behavior factor will be there or not. And the spectrum parameter, like this Sol factor and the spectrum's parameters can be specified. And peak ground acceleration, importance factor, and the viscous damping ratio can be specified. So this function is now there. And then what we need to do is generating response root case. When we specify the response root case, we can specify the function in the global X or Y direction or any angle based on the specified excitation angle. If the bridge, the major axis is different from X and Y direction, we can specify desired angle here. And we can specify the modal combination type and the sign, whether we want to restore the sign or not, which was ignored during the modal combination. And the desired modes, which will be combined for this modal combination. And damping method can be specified from here, like the modal damping or Rayleigh damping. And then finally, we can specify the response spectrum function. So this function will be used for the response spectrum analysis. Also, the modal analysis must be performed for this response spectrum analysis. So modal analysis, we can go for the eigenvector or risk vector. And for the eigenvector, we can go for the subspace iteration or Lanczos with the stump spectrum check. When we go for the risk vector, we can specify the desired number of modes for each of the vector direction. So after that, we can perform the analysis and we can check the results for the response spectrum. Also, the mass must be considered for this response spectrum function. This mass can be simulated using the self-weight of the model that we have generated. Here in the structure type, we can see the convert self-weight into mass. By simply checking on this option, the mass of entire structure can be considered. But there could be some of the components which was not modeled in the analytical model. So for example, the second dead load, if we want to consider this second dead load also for the mass, we can do that using the load to mass function. As you can see, by selecting the desired load case, second dead load, and then entering the vector, we can automatically convert the stating load into mass. So they can be considered for this dynamic analysis. So under the structural type, there is the major function that convert self-weight into mass. So this self-weight that we have considered under this stating node, that can be automatically considered. Okay, so I think there is no further question. So I would like to finish today's webinar. As I briefly showed you, we are going to visit Romania. So we hope to meet you in the technical seminar, which will be held in the November 5th. Thank you very much for attending today's webinar.